Hello and welcome. Before we begin this problem, I suggest you pause the video, read it, and try it on your own. Alright, so this problem says officials in town use a function C to analyze traffic patterns. So we're already establishing that the capital letter C represents the function or relationship that we're dealing with here. C of n, right? This is not C times the variable n. This C of n, this reads as C of n, and that just means the output based on the input n. So here input equals n. That determines what the output of the function is. So it's a function C based on the input n. That's the idea. C based on whatever we're inputting for n. And this represents, as they're saying, the rate of traffic. So this function is going to tell us the rate of traffic based on n, so n is probably the number of cars or something, through an intersection. So we're looking at traffic through an intersection, where on here they tell us what n is. N is the number of observed vehicles in a specified time interval. So let's just translate what they've told us so far. They're saying that the function C of n is a function that represents the rate of traffic. So this is C is the function that represents the rate of traffic, and it's based on the input n. That means, and since n is the number of observed vehicles, right, they're saying that the rate of traffic is depending upon the number of observed vehicles. And that's just a really precise and mathematical way of saying the number of cars is going to tell us how fast the traffic is moving. That's the idea. So they're asking what would be the most appropriate domain for the function. So the appropriate domain, that's another way of saying all the values, domain, you would find in the input, right? So the input is the number of observed vehicles, and the types of inputs we get is called the domain. So in other words, if you're counting the number of cars, which of these number sets would represent the way you count those cars? And here we can eliminate three choices. If we eliminate one, because I wouldn't count, right, cars as negative values. That wouldn't really make sense. And the dot 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 implies that there were more cars in the negative direction and more in the positive. We don't count cars with negative numbers. Same thing for 2. Here, 2 would also be kind of weird, and there certainly aren't negative cars. It doesn't work. Choice 3, we wouldn't use halves or 2.5 cars. At least I hope we wouldn't find a half car at our intersection. I don't know what would have happened to the other half. So really the only logical choice is choice 4. And I think 4, these dot 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 implies that the counting kept going on. 0 cars, then 1 car, then 2 cars, 3 cars, and so forth. The other word you might want to recognize is the range. The rate of traffic here, that's our output, right, or range. So in this problem, what would represent that? Well, that would be the speed, perhaps, of the cars as they move through the intersection. So that kind of set would be a series of speeds of cars. In that case, you might get all kinds of decimals, like 1.5 miles per hour or something, and the range would be quite different. But here we're counting the number of cars, so 4 is the best choice. Thanks.